Hello there, my name is Neil Jersey Natalis, and today we are going to be talking about basic integration. So to start, we have here the integral of ax raised to n dx. Now, this is the basic formula, the power formula. So if we integrate ax raised to n dx, we will have copy ax raised to n plus 1 on the exponent, then copy the exponent on the denominator, that is n plus 1. After that, we add a constant of integration denoted by the letter c. Now this is what we call the power formula. Now please forgive me for my handwriting. One of those people that are not very good, does not have a good handwriting. So for example, we have x squared here, x squared dx. Now we can see that there's no constant here, or a. We will only use the x raised to 2. Then from the formula we add a 1 on the exponent over the denominator 2 plus 1, and add a constant of integration, that is c. So to simplify, we have x cubed over 3 plus c. That is the final answer for this example. Next example, we have 4x raised to 5 dx. Now as you can see, we have 4 here as a constant, and we're not gonna be doing anything to the constant, so we bring out the constant. We have 4 integral of x raised to 5 dx. So as you can see, it makes things easier to understand for you. So we copy 4 and multiply the integral of x raised to 5, that is x raised to 5 plus 1, that is x raised to 6 over 6 plus the constant of integration. Now to simplify, divide 4 and 6 by 2. We will have 2x raised to 6 over 3 plus the constant of integration, and that is the final answer. Moving on, we have here a logarithmic function using integration on logarithmic functions. So as formula to understand here, we have a over x dx. Now this is equals to, the integral of a over x dx is equals to, copy the constant a, and then x, since we cannot use the power formula for that, we just use ln, absolute value x, plus the constant of integration c. Now using this formula, we can solve problems like this. So for example, we have the integral of 4 over x dx. So same as before, we bring out 4 since it's a constant, and then what we have left is 1 over x dx. Now, to also be able to understand this, since 4 times the integral of x, if we bring up x, we have x negative 1 dx. So if we use the power formula for that, we got x is to negative 1 minus 1 over negative 1 minus 1. Now x negative 1 plus 1, negative 1 plus 1. As you can see, this will become 0 and 0. So this will not be possible. So what we're going to do is, using this formula here, we'll have 4 ln raised absolute value x plus the constant of integration, and that's the final answer. Next example, we have the integral of 4x squared plus x minus 7 over x dx. So what we're going to do here is we integrate each term individually. So we bring out 4, and then the integral of x squared is x raised to 3 over 3 plus the integral of x is x squared over 2, and then next we have here, it's similar to the problem before, negative, we bring out 7, and then ln x plus c, and that's it. That is the final answer. Next, we are going to be talking about exponential function, the integral of exponential functions. So we have here for the e, or Euler's constant, the integral of Euler's constant raised to bx dx. Now for this function, we'll have first function, the integral of e raised to bx is simply e raised to bx, and its constant b will be copied below on the denominator, and then just add the constant of integration c, and that is it. As you can see, in if we derive the function e raised to bx, yes, we will have the constant b, and then just copy e raised to bx dx. So as you can see here, it's the same as the answer on above, only that the b here is cancelled out by the b on the denominator. So in the end, we have e raised to bx and e raised to bx. Now, for example, we have e raised to 2x dx equals, as you can see, this is just equals to the integral of e raised to bx dx equals to, same as the formula above, we have e raised to 2x over the constant 2 plus the constant of integration here, and that is the final answer. Another example, we have the integral of 1 over e raised to 3x dx. Now to solve this, we will bring up e raised to 3x to its numerator, and then the exponent will become negative 3x dx. So if we use the power formula for this, no, we can't use the power formula for this. It's the same as formula above here, this formula. So we copy e raised to negative 3x and then bring down the constant on its exponent, which is negative 3, and then add the constant of integration. So that's it. That's the final answer. Okay, next we have trigonometric functions, in the integration of trigonometric functions. So first, let's recall each integrals of each trigonometric. So first we have sine x, sine bx dx. That is equals to negative cosine bx over b plus the constant of integration. Next is cosine bx dx. This is equals to sine bx over b plus c. Okay, next we have secant squared bx dx. This is equals to tangent bx over b plus c. Next is cosecant squared bx dx is equals to negative cotangent bx over b plus c. Next is secant bx tangent bx dx is equals to secant bx over b plus c. And last is cosecant bx cotangent bx dx is equals to negative cosecant bx plus c. Now these are just the basic integrals of trigonometric functions. There are also other integrals of trigonometric functions. So first, let's have an example. We have sine 3x minus cosine 4x plus secant squared x over 2 dx. So first, to make it easier, we will use the sum difference rule for this. Minus integral of cosine 4x dx plus secant squared x over 2 dx, like that. Now we integrate them individually. So sine 3x is negative cosine 3x, and constant 3 minus sine 4x, and it's constant 4, plus secant squared is tangent x over 2, and x over 2 is just 1/2 plus c. So like that is the final answer. Or if you want to simplify it more, we have negative 1/3 cosine 3x minus 1/4 sine 4x plus 2 tangent x over 2 plus c. Yeah, that. Okay, next problem. Next sample problem, we have one half cosecant squared 2x plus secant cube x tangent cube x minus cosine 3x cosine squared x dx. So first we bring out the constant 1/2, and then the derivative of cosecant squared 2x is negative cotangent squared x over 2. Sorry, it's just tangent x plus secant cube x over this is sorry, I was wrong. These are supposed to be constant. 3 and 3, those are supposed to be constant. Secant cube x over 3 minus sine 2x over 2 plus the constant of integration. Now to simplify, we will have negative 1/4 cotangent x cotangent 2x plus 1/3 secant 3x minus 1/2 sine 2x plus c. That is the final answer. Now, next we will move on to U-substitution. This is one of the techniques of integration by substituting u and du. So first let's introduce the general integration formulas using the U-substitution. We have number 1, integral of u, this is the variable u, and the n, du is equals to u and plus 1 over and plus 1 plus c, just like the power formula. Okay, next we have du over u. If you still remember your logarithmic integration, integration of logarithmic functions, this is equals to ln absolute value u plus c. And next is Euler's constant over u du. Now this is same as exponential functions. It's just e raised to u plus c. And then number 4, we have the integral of the constant a u du. This is equals to a raised to u ln a plus c. That's all for the general integration formulas. Now next I'll be explaining how the U-substitution works. First, we have an example here. We will have x dx all over x squared plus 4. So what we're going to do here, by using the U-substitution, we'll look for the term or the variable that we're going to use to substitute u with. So in this function, function here, we will be using x squared plus 4. So u is equals to x squared plus 4. Now note that by choosing which to substitute as u, we will choose the one that in which we can substitute. We can also substitute its derivative of u to dx. So u is equals to x squared plus 4. The derivative of du or of u is 2x dx. As you can see here, it has the same. It looks familiar to x dx here. So what we're going to do next is we're going to add a 2 here. So to add a 2, so 2 over 2 is equals to just 1, right? So we add a 1/2 here so that we can put 2x dx. So we'll put a 2 here over x squared plus 4. Just copy that. Now do you see what we're going to be doing here? From its name, the name of the technique, U-substitution, we can say we will substitute u and du. So 1/2, just copy 1/2, and then as you can see 2x dx are the same, so substitute that, and then x squared plus 4 and x squared plus 4, you will also substitute that with u. Now do you remember where this came from? It's the same as this one, number 2, from the general integration formula. So if we integrate this will become 1/2 times the ln of u, absolute value u, and add the constant of integration. There, that's the final answer. Pretty easy. Now next example, we have the integral of x plus 1 dx all over x squared plus 2x minus 4. Sorry for my writing here. So first things first, what are we gonna do? We will look for the variable that we'll be using to substitute u with. So in this function, we will substitute u with x squared plus 2x minus 4. Now next is that we're going to find the derivative of u, which is 2x plus 2 dx. Now what are we going to do next? We have x plus 1 dx up here. We have a square root here. So 2x plus 1 is simply just x plus 1 multiplied by 2, right? So the same as the first problem, we will add a 1/2 here, so we can add a 2 next to x plus 1 here. I'll just copy x squared plus 2x minus 4. Now do you understand what we're going to be doing here? 2x plus 2 dx all over x squared plus 2x minus 4. Okay, now we are going to substitute what we have here. It's the same as this one, same as that one also. Now next is this equals to, just copy the constant, and then integral sign 2x plus 2 dx is equals to du all over the square root of x squared plus 2x minus 4, that is equals to u. Now this is just also basic integration by just using u. It's the same as bringing up the square root of u, which is equals to u raised to negative 1/2 and du. Now if we integrate u raised to negative 1/2, we will get u 1/2 over 1/2. As you can see, negative 1/2 plus 1 is just 1/2. So using the power formula, we will have this one plus the constant of integration. Now to simplify, 1/2, the 2 on 1/2 will be brought up here to the numerator. So that is just 2 divided by 2, that is equals to 1. So cancel out. What we have left is just u raised to 1/2 plus c, or it is x squared plus 2x minus 4, or its square root plus c. And that is the final answer. Okay, the next technique of integration is integration by parts. So this is pretty much similar to U-substitution, but instead we will be using this formula here. So the integral of derivative of u v, the integral of uv is equals to u dv plus v du. Oh no, I'm sorry, that was wrong. The derivative of uv is equals to udv plus vdu. Can get this by using the product rule by deriving u and v using the product rule, and this is what we get. So this is the formula for integration by parts. So you get the u, the du, the v, and the dv. On the function we can get u and dv, but it's much easier to explain with the problem. So first up we have ln x dx. Now this can't be solved using the U-substitution or any other technique of integration, so we'll be using integration by parts. So first look for the u, and the only variable we can see here is ln x. Now look for the derivative of u, it is 1 over x dx. Next is look for the v, it's v, it's simply just u, but it's for another substitution. But since we can't find the v on the function, first we will look for the dv. So what's left here is the dx, so we'll be using dx here. And if we find the integral of dx, there's simply just x, just either dx, or if you still remember your algebra, there's always a 1 here, 1 dx. Okay, next we will use the formula of uv minus the integral of v du. Now this is the integral, this is the formula for integration by parts. Okay, substitute u, v and du. So it will become x v, and then ln x for u minus v again, that is x, and then the du, which is 1 over x dx. So you can already guess what we're going to do here. We will cancel out x and x here, since x over x is simply 1. So what we have left will be x ln x minus the integral of dx. Now the integral of dx is the same as this one here, so the answer will be equal to x. So x ln x minus x plus c. That is the final answer. You can see that after substituting uv here, we didn't need to change it anymore, because there's nothing to change or solve. But instead, for the integral of vdu, since we still need to integrate it, so this is what we have got. Okay, next problem. Next problem. Let's see. We will have the integral of x sine x dx. Now, same as the earlier problem, we'll look for the u, the du, the v, and the dv. And since u and dv are the only ones that we can get from the function, we'll look for the u, and usually the u is the variable x raised to n. So next, look for the derivative of u, that is just dx, and then for the dv, it is sine x dx. Now we'll look for its integral, that is equals to negative cosine x. Now substitute uv minus derivative of v du. Substitute, that is equals to x negative cosine x minus the integral of negative cosine x dx. Now this is actually very easy now. So first simplify the uv, that is negative x cosine x, and then bring out the negative sign, multiply with the negative sign, that is positive, and then the integral of cosine x dx. So now we have nothing to do here, so we'll find the integral of this term. So just copy, plus the integral of cosine x dx is sine x dx, sine x plus c. And this is the final answer. One more problem to fully understand it, to better understand it. We have the integral of arc tan x dx. Now arctan x is, now we will look for the u, the du, v, and the dv as usual. Now the u, we can have arctan x as the u. So arctan x. After that, we will find the derivative of arctan x, which is equals to 1 over 1 plus x squared dx. Then what we have left is dx, right? So that will be our dv, and the integral of dx is simply x. Now once again, substitute uv minus the integral of v du. This equals to, substitute x arctan x minus v du, integral of v du x multiplied by 1 over 1 plus x squared dx. Now next, what we are going to do is use U-substitution for this integral here. So using U-substitution, this only so that you can understand better. Using U-substitution, we will use 1 plus x squared as our u, and then find the derivative of the u, that is equals to 2x dx. Now what we are missing here is the 2, right? So from the earlier examples from the U-substitution, we will add, now low back, we will add the u arctan x minus 1/2. We'll add the 2 here, and then 2x dx, since we still have the x right here from the v, over 1 plus x squared. Okay, next substitute u and du. Done. X minus 1/2 integral of du over u. Now this feels familiar, right? So x arctan x minus 1/2 integral of du over u is ln absolute value of u plus c. Now revert u to its original x. So 1/2 ln value 1 plus x squared plus c. Now this is the final answer. That is all for today. Thank you for watching. I hope you enjoy.